Hello students, we continue with the revision of work and energy and we start with the second part. So second part mainly discusses about energy. So the first and foremost is the definition of energy, which is defined as the energy possessed by an object is its capacity of doing work. So its SI unit is similar as that of work done. Therefore, SI unit of energy is joule, which is denoted by the symbol capital J. Sometimes we may have to use higher or bigger unit for energy. Hence, it can be used as kilojoule, where 1 kilojoule is equal to 1000 joules. The sun is the biggest natural source of energy. Here we discuss some forms of energy, and those forms are mechanical energy, heat energy, chemical energy, electrical energy, and light energy. Whereas some sources of energy are the sun, nuclei of atoms, interior of the earth, and the tides. Next, we come to one form of energy, which is the kinetic energy. So we all know that a moving object can do work, and hence we can say that it possesses energy. An object moving faster can do more work than an identical object moving relatively slow. Therefore, we define kinetic energy as kinetic energy is the energy possessed by an object due to its motion. The kinetic energy of an object increases with its speed. The kinetic energy of a body moving with a certain velocity is equal to the work done on it to make it acquire that velocity. This is an important point, that the work done is equal to the change in the kinetic energy of an object. Okay. Next, we move on to derivation for kinetic energy. So the derivation or the equation, mathematical equation for kinetic energy is Ek is equal to half mv square. So here we are going to derive that relationship. So we consider an object of mass m, which is moving with a uniform velocity v, which is displaced through a distance s. And for this, a constant force F is acting on it in the direction of its displacement. And therefore, its velocity changes from u to v. And as there is change in velocity, let a be the acceleration produced. So we know that v square minus u square is equal to twice as. If we rearrange this equation, we get v square minus u square is equal to 2a. So we obtain the value of displacement s in terms of initial velocity, final velocity, and acceleration. Let's call this equation as 1. We all know that by the second law of motion, we have force F is equal to mass into acceleration. Let's call this equation as 2. And we know that work done, by definition, work done W is equal to F into S. So substituting values of force F and displacement S from the equations 1 and 2, we obtain W is equal to ma multiplied by v square minus u square upon 2a. So here, by reducing acceleration both at numerator and denominator, we obtain W is equal to half into m into v square minus u square. Now, if we assume that the object is starting from rest, its initial velocity u will be equal to 0. And therefore, the above equation reduces to W is equal to half mv square. Now we can state that the kinetic energy possessed by an object of mass m and moving with a uniform velocity v is given by Ek is equal to half mv square. So we have to use this formula to solve some of the numericals. So here we consider a couple of numericals. An object of mass 15 kg is moving with a uniform velocity of 4 meters per second. So what is the kinetic energy possessed by the object? First, writing down the given, m is equal to 15 kg, v is equal to 4 meters per second. To find is Ek, that is the kinetic energy. We start the solution by writing down the formula for finding kinetic energy, that is Ek is equal to half mv square. Substituting the values, we get Ek is equal to half into 15 into 4 into 4. By calculating, we get Ek is equal to 120 joules. Therefore, kinetic energy possessed by the object is 120 joules. We consider next example. So here, certain force acting on a 20 kg mass changes its velocity from 5 meters per second to 2 meters per second. And here we have to calculate the work done by the force. Interestingly, we have discussed the formula for finding the kinetic energy, and the question under consideration here is about work done. So as we start solving the question, you'll find the correlation between work done and kinetic energy here. Writing down the given, m is equal to 20 kg, initial velocity u is equal to 5 meters per second, v is equal to 2 meters per second, and we have to find work done w. Now solution. In the previous slide, we had discussed that work done is equal to change in kinetic energy. That is, work done is equal to final kinetic energy minus initial kinetic energy. By substituting appropriate values, we get W is equal to half mv square minus half mu square. We rearrange the terms, thereby getting W is equal to half into m into bracket v square minus u square. Now we substitute the values so that we get W is equal to half into 20 into 2 square minus 5 squared. As we carry out the calculation, we get W is equal to minus 210 joules. So in this case, work done by the force is minus 210 joules. So this is an example where work done is negative. That is, the angle between the force applied and the direction of displacement is 180 degrees. Next, we come to potential energy. By definition, the potential energy possessed by the object is the energy present in it by virtue of its position or configuration. So when we say by means of or by virtue of its configuration, the examples are of the spring or a bow. Okay, so spring or bow, they possess potential energy by means of their specific configuration. But this year, we are considering the potential energy due to gravitational force, that is gravitational potential energy. The definition states that the gravitational potential energy of an object at a point above the ground is defined as the work done in raising it from the ground to that point against gravity. An object in a given position can have a certain potential energy with respect to one level and a different value of potential energy with respect to another level. The way we discuss derivation of kinetic energy, here we discuss derivation of potential energy. So we consider an object of mass m. Let it be raised through a height h from the ground. A force is required to do this. Therefore, the minimum force required to raise the object is equal to the weight of the object. And we know force F is equal to mg. And we also know that energy gained by the object is equal to work done on it. By definition, we know work done W is equal to force into displacement. In this case, force F is equal to mg. We substitute it here. Displacement is along the vertical direction, which is h. So we get mg into h, that is W is equal to mgh. Energy gained by the object is the potential energy of the object, or it is the work done on the object. Therefore, we get potential energy EP is equal to mgh, that is product of mass acceleration due to gravity, and the displacement or height. To understand the formula further, we consider some numericals. So find the energy possessed by an object of mass 10 kg when it is at a height of 6 meters above the ground. Given is g is equal to 9.8 meters per second square. Writing down the given information, m is equal to 10 kg, h is equal to 6 meter, g is equal to 9.8 meters per second square. We have to find potential energy EP. Writing down the solution, write down the formula first, that is EP is equal to mgh. Substituting the values, we get EP is equal to 10 into 9.8 into 6. Carrying out the calculation gives us the value of EP, which is 588 joules. Therefore, the final answer is energy possessed by the object is 588 joules. Next, we come to law of conservation of energy. So what does that law state? Law of conservation of energy states that energy can neither be created nor destroyed. It can be converted from one form to another. That is, the total energy before and after the transformation remains the same. So for our given scenario, or for our given scope, we have kinetic energy plus potential energy is equal to mechanical energy. That is, kinetic energy plus potential energy is equal to constant. And by substituting the formulas, we get half mv square plus mgh is equal to constant. Now, during the free fall of the object, we all know that during the free fall of the objects are continuously under the influence of acceleration due to gravity. So during the free fall of the object, the decrease in potential energy at any point in its path appears as an equal amount of increase in kinetic energy. Please note here the effect of air resistance on the motion of the object has been ignored. There is thus a continual transformation of gravitational potential energy into kinetic energy. So here we come to the end of the second part. We'll continue in the third part.